Okay, so this video is to help understand absolute dating and calculating half-lives. Absolute dating measures the age of objects, such as fossils, rocks, etc., based on the radioactive decay of atoms. Unlike relative dating, this gives us a numerical age. Half-life is the amount of time it takes for half of the atoms in a radioactive substance to decay. So, for the purposes of my class, the way we will always set up these problems is like this. Time over amount. Okay, so an example of this. I would put, so if I'm always starting in a situation where it's going to be asking me after a certain amount of time how much is left or something to that effect. So we're going to start it like this. At time 0, the present, the timer has just now started, it is at 0. So the time over our amount. Now that could be 1,000 grams, or maybe 0 over 20 atoms. It's always going to be our time in seconds or days or weeks or years or something like that. So then we're going to, our second step, the top will always add the half-life. The bottom will divide by 2. So here, if our half-life, say, is 10 seconds, we're going to add our half-life and divide this bottom one by 2. Okay? Then we're going to add the half-life again. Okay, so that's, again, if our half-life is 10 seconds, one half-life is 10 seconds, 2 half-lives is 20 seconds. Okay, and the bottom, again, is going to divide by 2. Here we would now have 250 grams. So say a question asked you, this radioactive element has a half-life of 10 seconds. How much of a 100-gram sample will remain after 2 half-lives? Here's my first half-life. Here's my second half-life. That would be my answer. Okay, so let's do some real examples here. So here, this is one that we've done in class. Fluorine-21 has a half-life of approximately 5 seconds. If there is a 1,000-gram sample, how much would be left after 30 seconds? So again, we're always going to start it the same way. At time 0, let's get this, there we go. At time 0, we have 1,000 grams, okay? This top one, we're going to add the half-life, which is 5 seconds. So 5 seconds. And then we are going to divide this one by 2. So that's 500 grams. Okay? But this one says to go all the way to 30 seconds. So 10 seconds is 250 grams. So again, we add... We don't multiply. Sometimes we have some people getting tripped up by doing by multiplying the top. We're not multiplying. We're adding the half-life. So first half-life is 5 seconds. Second half-life is 10 seconds. Third half-life would be 15 seconds. Now it's this bottom part, the amount, right? The amount of the sample is decreasing. It is decaying. It is going down. time always increases, the amount decreases. So this bottom one is now at 125 grams. Oops. And then we keep going until we get to the correct answer. "25 seconds is 31.25 grams. And then our last half-life, where it's asking 30 seconds, is 15.625 grams. So our answer to the question, how much would be left after 30 seconds, is 15.625 grams will be left after 30 seconds. So, you can pause the video and try this next one on your own, and then watch me do it. So the iodine 131 has a half-life of 8 days. If the original sample is 600 grams, how much would remain at the end of 32 days? Again, start the same way. We start at 0. Our time is 0 days, and our amount is 600 grams. Okay? We add one half-life, so our first half-life would be 8 days. We divide by 2 on the bottom. Now we're left with 300 grams. Our second half-life is 16 days. 8 plus 8 equals 16 days. Divide the bottom by 2. 150 grams. Now, here, this step is where I see a lot of people make a mistake. They'll jump straight to 32 days. They get the answer of 75 grams, which is not right. Because again, we're adding the days, not multiplying by 2. Okay, so 8 plus 8 equals 16, plus 8 equals 24. So our third half-life is 24 days, 75 grams. And we still have one more step to go. 24 days plus 8 days equals 32 days. And then we have 37.5 grams. And that is our answer to the question. How much would remain at the end of 32 days? 37.5 grams. Okay, let's try. We're going to skip number 3. It's a little time consuming. Let's move to number 4. Now this one asks us in a different way. So again, you can pause the video, try to do it yourself, and then play it when you're ready. Okay, so this one, again, we can still set it up exactly the same as we've been taught. So at time 0, in this case, time 0 is 1 o'clock p.m. So at 1 o'clock, the time, we have 20 grams. Okay? It wants to know how much, what is the half-life? So we don't really know this top part, but we can fill in as we go. So, leaving the top blank, half of 20 is 10. So, clearly it's not 1 hour, because 1 hour, if that was the half-life, it would have already gotten to 5. It is not. So, clearly it needs 2 half-lives. 10 divided by 2 is 5. So it needs 2 half-lives in order to get to 5 grams by 2 o'clock p.m. So what is halfway between these two? 1:30 p.m. Okay, therefore, our half-life, the time it takes to get from here to here and to get from here to here, the time it takes for half of the atoms, half of the amount of a radioactive substance to decay, in this case, is going to be 30 minutes. Okay, let's skip number 5. We're going to try number 6. Again, pause the video if you want to try it on your own. Okay, so carbon-14 has a half-life of 5,730 years. After 6 half-lives, what fraction of the original nuclei would remain? Now, this one is a little bit tricky because they give you this information, which is not exactly necessary. Now, could I calculate it and add up all those numbers a bunch of times? Yes, technically I could. I wouldn't arrive at a wrong answer because it's not asking for what's on the top of that setup that we have. It's asking for the bottom. So, again, I can use times 0. I have or 100% or 1. If we're using fractions, it asks for a fraction, not a percent. So I'm going to put 1. 1 whole is what we have at times 0. So again, I don't have to start calculating 5,730 and so on. I can just do 1 half-life, 2 half-lives, 3, 4, 5, 6. So we can always use this as a placeholder. Sometimes they don't even give us the half-life. It just says after 3 half-lives, how much would we have left? So you can always use these numbers as placeholders. And so on the bottom here, I'm going to use fractions. After 1 half-life, half is remaining. So down here, here's a half. Divide a half in half, that is a fourth. Divide a fourth in half, that is an eighth. Divide an eighth in half, that is 1/16. Divide 1/16 in half, that is 1/32. And divide 1/32 in half, and that is 1/64. So what fraction of the original nuclei would remain? 1/64 is your correct answer there. And now let's try this last one, number 7. Again, pause the video now if you want to try it on your own before I show you how to do it. The half-life of iodine-125 is 60 days. If you have a 2,000 gram sample, how much would be left after 30 days? Or 360 days, I'm sorry. So let's try this. Okay, I'm going to set it up. At time 0, I have 2,000 grams. Okay, so 1 half-life is 60 days. We have 1,000 grams left. 2 half-lives is 120 days. That is 500 grams left. 3 half-lives, oops, I'm missing my units. Okay, after 3 half-lives, that's 180 days, 250 grams. $240 days. Again, we are adding our half-life. 60. 60 plus 60 is 120. 120 plus 60 is 180. 180 plus 60 is 240. Dividing our amount left in half, that's 125 grams. 240 days plus 60 days is 300 days. 125 grams, our amount divided by 2 is 62.5 grams. And last, we have 300 days plus 60 days is 360 days. That's what they were looking for. And we are left with 31.25 grams. Okay, so our answer was 31.25 grams is left after 360 days. Now, there is a similar way to do this. I'm going to show you it a little bit differently. So I'm going to erase this and I'm going to try it one more time. Now, this may be an easier way for you to think of it rather than having to switch back and forth with the math. So, okay, instead, I'm going to just go straight across with the time and then straight across with the amount. So, 60, 120, 180, 240, oops, 300, 360. Okay, again, I'm adding 60 every time. Now on the bottom, I'm going to go straight across. 2,000 divided by 2 is 1,000. 1,000 divided by 2 is 500. 500 divided by 2 is 250. 250 divided by 2 is 125. 125 divided by 2 is 62.5. And 62.5 divided by 2 is 31.25 grams. So again, I arrived at the same answer. Rather than doing it each one together, instead I went across the top and across the bottom. Okay, that is the end of this video. I can provide more questions in class for you to practice. Just let me know. Thanks for watching.